Okay. K Nearest Neighbours, KNN algorithm in supervised learning, which is used and classification. Predominantly used in classification, also used missing value imputation algorithm. K Nearest Neighbours or KNN is an algorithm which is used for both regression and classification, but predominantly used for classification and is also used as a missing value imputation algorithm. This is also used as a missing value imputation. KNN is one of the simplest algorithms based calculations as part of methodology. Distance methods, Minkowski, Mahalanobis are used. KNN is also used in text mining and distance. So KNN is a distance-based algorithm. It uses distance-based calculations for its computational methodology. Default distance is Euclidean. Default distance method is Euclidean distance. So text mining is different, right? So in text data, what we do is we have to convert the text to numbers. One way of conversion is frequency counts. We create a table of frequency counts of the text. How many times the text is appearing in different sentences or different tweets or different word. How the word, we'll break the text into words and we create a term matrix, document term matrix. That means in which how many sentences the word is coming, how many times the frequency. So using that frequency table, we will calculate the Hamming distance. I will show you the example, but when we discuss NLP, that time I will tell you how it is done. You can see here, Euclidean, Manhattan, Minkowski. This is the formula for Hamming distance. So if both the terms are equal, both the words are same, the distance is 0. If both the words are not same, it will be assigned a value of 1. And sum total of all the ones will be the distance. If the terms are same, or let me show you a detail. Actually, in NLP, we have that. Two statements, geeks for geeks, Java, C++, these are the two sets of words. Ignore the numbers, these are the words. Okay. We are trying to find distance between these two, A and B. Geeks to geeks is same, so 0. This is also 0. This is also 0. Now, these are different, Java and C++. So this will be 1. C++ and C, different, 1. This is same, this is same, this is same. So 1 plus 1, the distance is, okay. If the words are common, 0. If the words are not common, they will be 1. So this is how Hamming distance will work. We will talk about it in detail when we do text mining, natural language processing. So another common question is when to use which distance metric? Text similarities. So for Euclidean distance, the features must be continuous and numerical. Euclidean distance is used when your data is numerical and continuous. And it is the default method. Euclidean distance. So when your data is in numerical format, Euclidean distance is used. Shortest distance between 2 points. Euclidean distance will give you shortest distance between 2 points. Google Maps uses Euclidean distance in calculating distance when it shows the distance between 2 points or 2 vectors. Google Maps uses Euclidean distance. The next popular is Manhattan distance. It is more effective when you have discrete or binary variables present in the data. Manhattan distance is widely used discrete or binary variables. When your data is discrete or binary, zeros and ones, Manhattan distance. Euclidean for numeric data, Manhattan for binary data. If your more of your variables are binary or non-numeric categorical, use Manhattan distance. If most of your variables are numerical and some variables are binary, you can use Euclidean. Say 80% are numerical, 20% binary. You can go with Euclidean. But if it is 80% binary and 20% numerical, we have to go with Manhattan. Hamming is for strings. If you are dealing with text data, Minkowski is combination of both Euclidean and Manhattan. Minkowski is combination of both Euclidean and Manhattan. It can be used both on categorical data as well as on numerical data. Minkowski is a combination of both Euclidean and Manhattan. Plagiarism check happens based on using or it can be based on Euclidean distance also. So basically what happens is two parameters are considered. How many words are similar and the pattern similarity, how similar they are repeating. That is how it will be taken into consideration. Now, in KNN, K is an integer which needs to be given. Is an integer, the number of neighbors to be considered. There is no fixed formula for identifying exact value of K and is determined and error. You have to give the value of K, which is number of neighbors to be considered. How many neighbors to be considered, that you have to give. Multiple, first build it with K is equal to 2, then build with K is equal to 3, K is equal to 4. You build all, you can do for loop or you can do grid search. Grid search is nothing but for loop only. For all distance-based algorithms, scaling must be, when you use distance-based algorithms, we will also study another set of distance-based algorithms called K-means. Wherever you see distance-based algorithms, scaling must be done. Standard scaler or min-max scaler or robust scaler must be implemented. For text, we don't do scaling. Scaling will be implemented only on numerical data. You remember, I was very clear. You cannot scale non-numeric categorical data. That's why now we separate num calls and then do we scaling. We don't do it on object calls and cat calls. This is again a common interview question. Can you scale dummy encoded variables? No, you cannot scale dummy encoded variables. Scaling will be implemented only on numerical continuous variables only. So there is no scaling for binary or dummy encoded variables. KNN is a non-parametric algorithm. KNN is a non-parametric. What is a non-parametric algorithm? No what? The right word is no prior. What is the other non-parametric algorithms we have discussed? Non-parametric algorithms. Tree-based models. Decision tree, random forest and gradient boosting. All tree-based models are non-parametric. Okay. Similarly, KNN is also a non-parametric algorithm. It is also called lazy algorithm as it will only when in all other algorithms, the calculations are done and a model or a equation will be stored in the memory, which will be used for prediction. Whereas in KNN, only data will be stored in the memory, not the models or the equations or the calculations. Once you give something data to be predicted, then it will start the calculation. That is why it is called as lazy algorithm. Okay. Now look at this data. We have to classify this gray point. It has 3 levels to classify: yellow, green, and orange. 3 classes are there. This is a multinomial problem. We have to classify the gray. Okay. Now, assuming k is equal to 1, 2, 3, 4. We have assumed k is equal to 4. That means from this point, it will identify 4 closest observations and calculates the distance between them using the Euclidean distance. See, first, second, third, and fourth, these are the distances. So which is the nearest neighbor? 2.1 line. So lime yellow will win the one. The point is therefore predicted to be lime yellow. So first, it will identify, you have to give the value of k. The value of k is also very important. If you say k is equal to larger k, if you give, the more values it will take into consideration, the more neighbors and the more distances it has to calculate. If you give too small, it's also a problem. So when you are design, this is the basic functionality. This is how it will do. It will first calculate the distance between the neighbors and how many neighbors you have to specify k value. Based on that, it will calculate the neighbors and the neighbor which has the lowest. See, 2.1, 2.4. 2 neighbors are closest. So only 1 green and 1 orange is closer. Majority voting. 2 lime yellows are closer. It votes the majority class and then it will, the k value lead to, and if it is too many calculations, so optimal k value must be given, must be used k value. Now let us go to the calculation sheet. We have 2 independent variables to predict the 2 independent and dependent variable t-shirt size. Height is 166, weight is, what is the t-shirt size? Like I told you, we must scale the, so what is the formula for standard scaler? X minus mean divided by standard deviation. Standard scalar is also called as z-score. X minus mean divided by standard deviation. That means we need to calculate and standard deviation of the is equal to average. Select the column, close bracket, enter. Simply drag the formula to left. Is equal to STDEV, close bracket, enter. Drag it to the left. This is the formula for mean and standard deviation. Calculated the mean and standard deviation. Now we will do the scaling. Underscore scale. Height underscore scale is equal to open bracket. So mean is constant for all. So press Fn plus F4 to put the dollar signs. Standard deviation, which is also common to all, Fn by Fn plus F4 is equal to open bracket x minus mean Fn plus F4 divided by standard deviation, again Fn plus F4, the $2 signs. Some laptops it is F4 directly. In most laptops it is Fn plus F4 to insert the dollar signs. Absolute cell referencing is equal to open bracket x minus mean close bracket divided by standard deviation Fn plus F4 minus 0.924. Double click, it will calculate for all. Similarly, weight underscore scale. Now we also need to scale the predicted values. Is equal to 166 minus mean divided by standard deviation. What average will change? So Euclidean distance is equal to SQRT, open two brackets, minus x1 is equal to 166, which is scaled, that has to be fixed, minus x1 to the power of 2 plus y2 minus y1 to the power of 2 is equal to SQRT, two brackets, the predicted values, x2 minus x1 whole square or y2 minus y1 whole square. x2 is common for all. So fix it by pressing F4 minus the x1 value, close bracket to the power of 2 plus open bracket y2. y2 is common, Fn plus F4 minus close bracket to the power of 2 close bracket. Press enter and double click the. So square root of x2 minus x1 whole square plus y2 minus y1 whole square. x2 and y2 you have to fix because they are common. We are calculating the distance from x2 to all other points. So x2 has to be fixed by pressing Fn plus F4. x1 value will, so x2 value, y2 value, which is the height and weight, they have to be fixed by pressing Fn plus F4. Rest of the x1, y1 values should change. As we drag the formula, they should. So this is the formula. Square root of. Divided by standard deviation. Where is that one? Data is to B19. Calculated in B21. So B19. We made it wrong. You didn't fix it. FNF4. Where is FNF4? If you don't give FNF4, when you drag it, it will go to zeros. All of you got the Euclidean distance? Now select the Euclidean distance. Sir, if we take K value as 3, I'll tell you. Yeah, top 3. We have to first sort the distance. Euclidean distance, control shift down arrow, sort and filter, smallest to largest. Smallest distance, right? So select the distance column, home tab, sort and filter, smallest to largest. Don't select the header, only the numbers. And expand the selection. You guys calculated the distance? I'll come down. So if you assume K is equal to 3, assume K is equal to 5. First 5, majority voting. Here all are same. So we are taking it as 5. So you have to sort the distance from smallest to expand selection. The model? Yes, the model performance is depends on K. You didn't put the denominator. Standard deviation also has to be fixed. Mean has to be fixed, standard deviation has to be fixed. That how will you fix? Then it will not move, no? It has to move. Only mean and standard deviation has to be fixed. Mean and standard deviation has to be fixed. You are 0.462. Open bracket. 6 days. Open bracket. Standard scale will have both positive and So if k is equal to 3, top 3 are all else. So L. If k is equal to 5, again top 5 all are else. Majority voting. Whatever is majority, that will be taken. We take generally odd number. We generally take odd number. K is equal to 3, k is equal to 5, like that you can take. Because, and don't forget to sort. After sorting only, you will select the top 3 or top 5 and majority voting. What are the else? How many else are there? How many ends are there? The final prediction is? Yeah. Square root of what is the formula? X2 minus X1. What is X2? That is X1. That is not even where. You should not consider that. You should consider only scale value. X2 is this. This has to be selected. X2 is the value you are predicting now. Y2 is this. And you should only consider scale values as X1 and Y1. Now double check. Keep it like that, sort it. Smallest to largest. This is not like that. You should not select empty cells. You select the data range exactly. So, all right. Now copy the data into a new sheet. I will do regress also. Min max. So we have to find minimum, maximum. Is equal to min is equal to max is equal to min is equal to max is equal to min is equal to max is equal to open bracket x min fix it by pressing F4 close bracket divided by open bracket x max fix it by pressing F4 minus x min fix it by pressing F4. Except for x, all other has to be fixed by pressing Fn plus F4. X minus x min divided by x max minus x min. So the answer is 0.5833. Let me double click and then I will show you the formula again. X minus x min. Minimum is equal to min. Select the values. Divided by open bracket max. Fix it by pressing Fn plus F4 minus x min. Fn plus F4. Except x, all of them have to be fixed. Absolute cell referencing. Similarly, do it for weight. Weight underscore norm. See, all the values are between 0 and 1. No negative values. Min max scalar, no negative values. Only positive values, only between 0 and 1. Weight underscore norm is equal to open bracket x minus x min Fn plus F4 divided by x max Fn plus F4 minus x min Fn plus F4 close bracket. Now you have to scale these two also. Is equal to 166 minus 158 divided by 170 minus 158 is equal to 65 minus 58 divided by 68 minus now Euclidean distance. Sort and filter, smallest to largest, expand sort. Again, assume k is equal to 3. Alright, you can take your break. We'll meet after 15 minutes. Smallest to display.
Assume k equal to 3, k equal to 5. Again, divided with whole farm and farmer no W minus no W. Bigger carry set couldn't call రామాయణానికి ఎండ కొడతారు నీకు బస్ స్టాప్ వరకు ఎండ కొడతారు కొట్టారు బస్ స్టాప్ వరకు ఎండ కొట్టారు
Okay, do the regression problem with standard scalar. Use standard scalar on regression problem. So what are the values you have taken? Age is 28, zone is 75,000. All right, average and standard deviation. Average of 3. So if you take these 3, you can see in the bottom 172.67. It's not visible here, but in your screen you can see. Data pre-processing and feature. Feature engineering involves data pre-processing. See, feature engineering has many steps. One part is data transformation, scaling, variable selection, feature selection, dimensionality reduction. A lot of things are there in feature engineering. Data pre-processing limits to pre-processing of data like scaling, transforming only. Some part only will do in data pre-processing. Feature engineering is very wide, where you have variable selection also. Data pre-processing plus variable selection.
Variable selection, I think creating new variables.
No. You can see creating new variables is part of data pre-processing. You remember data pre-processing?
Yeah.
Removing duplicate columns, removing single value columns, missing value imputation, dependent variable transformation, independent variable scaling, creating new variables, dealing with dates. Okay. Then extracting information from alphanumeric codes. Okay. Then we also can do some mathematical calculations and ratio calculations. These all come under data pre-processing. Data pre-processing plus variable selection or feature selection. Variable selection or feature selection. There is a completely, when you have large amount of variables, you do selection. Now, variable selection or feature selection can be done manually. If you have domain knowledge, you can select them. You have limited variables, you want to select important variables, you can do them. Or you can use algorithms to do variable selection, decision tree, variable importance, decision tree, random forest, gradient boosting, neural networks, they give variable importance. There are dimensionality reduction techniques called principal component analysis, which group variables based on similarity into components. They reduce the dimension. They don't delete variables. In feature selection, we delete variables, right? Some zero important we delete. But in PCA, variables will not be deleted. They will be combined into components or groups. Dimensionality reduction techniques is there. Now, new sets of algorithms are also created. Select K-based methods using chi-square. So there are methods which are being developed, algorithms which will help you to identify important variables. In sklearn, they have been implemented. Last version of sklearn, they have been implemented. So data pre-processing plus variable selection on feature selection will become feature engineering. sklearn feature selection methods. See, variance threshold is a new method where based on variance, least variance it will be removed, maximum variance will be retained. Then univariate selections like select K-based, which is based on K neighbors, select percentile, generic univariate select, select FDR. There are methods which are being, because companies want methods, statistical methods for variable selection, apart from the tree-based models. Recursive feature elimination, that means one by one, it eliminates, backward elimination. Similarly, you have select from model. Select from model, you can give random forest, gradient boosting or something, it will select from that model. L1 based, we'll study regularization, L1, L2 penalty based selection. So what is happening in real-time data science is, you will face hundreds of variables. Sometimes principal component analysis is not giving us the required components and required model. So companies are looking for other ways other than the dimensional reduction techniques to look at it. So these statistical methods are developed where we can use these methods to select features. Where you don't have sufficient domain knowledge, you're not able to select based on the knowledge you have, you can use these methods. These are all statistical methods which are approved in industry. Select, feature extraction and feature selection. So data pre-processing is one part of feature engineering. Variable selection is the other part of feature engineering. Both will put together, we come under feature engineering. Because in data pre-processing, we don't select variables, right? Because by that time, we don't think about model building. After data pre-processing also, we do ADA. So data pre-processing plus feature selection or feature extraction will become feature engineering. That's a completely different subject. Now both put together. And why feature engineering? Because in reality, you will deal with hundreds of variables, and not that all the times you will have domain knowledge. If you don't have any domain knowledge, or if you are not having thorough domain knowledge and you want to do feature selection, you can use these statistical methods. These are unbiased methods. They simply go with they simply depend on the data.
We already select the variables, so the model also.
Model performance. See, the lesser the variables, the better the performance of the model. The more variables are there in the model, the lower the performance of the model. So you must give as much as possible lesser number of variables for the model to perform. So we have to do feature selection. So these feature selection methods which are being implemented are very used. And nowadays, I have seen some research papers well being developed for these feature selection also. Those methods are also very good. So you will be working on based on the domain, which method works well, you can use that method. But how many hypothesis tests will you do if you have 100 variables? You have 120 variables. You have 1 lakh rows, say 2 lakh rows or 3 lakh rows of data. How many tests you will do? Max you can do 10 or 12. And you can identify only 10. What about the others? There is a point, right, where you can't go beyond it. You can't spend on, see, if you have 100 variables, 100, see 100. How many combination, permutation combination, how many tests you have to do? Thousands of tests you have to do, right? Then it's a problem. So what you will do is, you will use these methods, variance threshold or select from model or some recursive feature elimination, some model you will use. Sometimes you have to do trial and error there also. You run multiple methods, do hypothesis testing, build model and see how it works. See, the problem is we can't fix the rules because data is not fixed. Data keeps on changing. So we can't fix rules like in other sciences. So you can fix in physics and chemistry that, it reaches this much of temperature, this happens. But that cannot be done in data science because data behaves differently for different geographies, different regions, different age groups. So we don't know what is going to happen. Now, if you are good in SQL, if you understand data science properly, when you are writing your SQL query, you will make sure the data remains. I have seen people writing, see, suppose the managers want to study the consumer behavior of young people. Young people means what? You have to take it from 18 to 35. I have seen people downloading all the data of 60 years also, and then you are trying to build models. Is that a right way? You will get a model. You will get a model, you get everything. But will it meet your objective? No, right? The objective is to study the consumer behavior of 18 to the young people, 18 to 35. So when you are writing a query, you get only the data of 18 to 35. And build a model on that data that will be robust. Now you put all the data of 18 to 35, 35 to 45, 45 to 60, 60 plus all the data comes in. You build a model, then your predictive probabilities will. So you have to focus narrowly on that one and then get exactly that data and then work on that data. So that has to be very clear. Objective has to be very, very consumer behavior of which age group or consumer behavior of which gender. Okay, gender is only 2, we can go with it, no problem. But if you're saying consumer behavior of education, there are so many levels of education. You'll get problematic, right? So you have to split it. We want me to look at school, high school, graduation, post-graduation like that. And then accordingly, you'll write the query, get the data, and then you work on that. So this is how you work on data science projects. So the objective has to be very, very clear. And you must get a data related to that particular objective only. That you have to make sure. I have seen in the previous instances, where students made that mistake, previous students, online betting that thing, they were targeting under 21 people. He has data of 30, 35, 40 years old also. But that should not be there, right? When you're targeting 18 to 21, you should look at that data only. What is the point of looking at 40 plus? So I told him, remove all the data of that one, remove all those records, get the 18 to 21 records, and then start EDA and exploring and analysis and come up with the model. So name-based, we worked on what? Credit card, right? We have done all the models on the credit card, right? Including neighbors. This credit card data. All of you have this one. Credit card default. Taiwan credit card default data set. We worked on it on cell run all. Oh, I got an error. First error. Okay, all of you ran. For neighbors also we have done till neighbors. Okay, shall we move forward? sklearn dot svc support vector classifier. SVC is equal to SVC. SVC model is equal to SVC dot fed x comma y. SVC x comma y. 77.89. SVC predict. SVC model dot. So area under the curve 0.50. It's not a good model at all. Now on this data, we will implement neighbors. Yes, no. Here data size is large. Support vector sometimes has a problem in terms of large data. See, for large samples, consider using linear SVC or SGD classifier. We have used SVC. So linear SVC is similar to SVC. I have used that one for large data only. Or we can use SGD classifier, which is support vector classifier with stochastic gradient. With stochastic gradient, you can do this SGD classifier. So there are different versions, but the one which is suggested for large data only, I've used linear SVC. So you have to go through this documentation, then only you will come to know which one is better and which one is not good. So if you look at the SVC for large data, we use a linear SVC, which is nothing but SVC. So basically we have tried using this model with the base fit model, it didn't work. So we have to go for other model. See, support vector was a statistical model. See, in statistics, anything about 10,000 is considered large. In statistics, sampling and all, anything about 10,000, they raise questions. But when you look at machine learning and data science, 10,000 is nothing. We get lakhs of rows. So that is where, if you stick to statistical rules, you cannot do model building. So we have to ignore certain aspects of statistics and we'll use those models. So we have to find the model which works with our data. Statistical rules does not work. So we have to go with trial and error, going with model by model, understand each model, whichever gives us the stable performance and result, that will be our final model. And model depends on data. It will always change. That is the reason why, see, ChatGPT, whatever it comes, they struggle if the data changes every time. Because automated versions will work on a standardized input, they will work well. But if the input constantly changes, what about them? They can't change themselves, right? Somebody has to fine tune them. So people think ChatGPT comes, everything goes up. No, there is always an element of human that has to be there to control and monitor the model building. That is where these guys wrote, Elon Musk and all. They have told governments not to use ChatGPT because it generates wrong results. If you are trying to understand government schemes in India, government schemes every month it will change. Some months people will take money, sometimes people will not take money. In between there is a corruption aspect. All of these things will come, and model cannot predict. And whatever predictions it is generating might be wrong. And if government follows those predictions, it is also wrong. You know, Arogyasri, the very popular scheme launched by Rajshekar Reddy, that they were trying to fix the rate of procedures. Okay, heart surgery, valve replacement this much, stunt this much, bypass this much. They were trying to, how they want to do based on the cost of surgeries done in government hospitals, private hospitals. They asked them to give them data. Government data they have. Each operation and all the data is there on paper. They converted it into digital mode, EMRI, Emergency Management Research Institute. That was one of the projects they did. They converted all the paper-based data into Excel files. Similarly, private hospitals, wherever they have Excel data, they gave, or they also gave the files only. After putting all these things, some hospitals were charging for bypass surgery 20 lakhs. Government rate is hardly 4.5 lakhs. Now, when you look at this 20 lakhs, the surgeon cost is 5 lakhs because surgeon is trained in US, FRCS, US, he has 10 degrees. He has spent crores of money on getting those degrees, right? Medical education is not cheap. So surgeon fees will be, obviously will charge according to his qualification. Whereas in government hospital, doctor's salary only will be there, na? And if they do additional surgeries, they get an incentive of 10,000 rupees. Same surgery, same procedure. Government doctor does, additional cost is 10,000 per surgery. Incentive. Minimum is 4 surgeries he has to do in a month. Above that he is doing, he will get 10,000 per surgery or 15,000 per surgery based on complications. They will do. Here, in private hospital, one surgery only, one doctor is 5 lakhs. So how will you model this behavior? So we can't do that, right? So we can't come up with a pricing. Even in US also same problem. Till now, procedure costs are not fixed. Some states, heart surgery is cheap. Some states, heart surgery is very, very costly. And if they come to India on medical tourism, it's very, very cheap. You know, Americans don't need visa on arrival. Americans don't need to get visa. Like, oh, we have to go wait for months for a visa. No. Americans can directly board the flight, can get down in Delhi, Bombay and Chennai, give their visa on arrival for 30 days and then without paying any money. And they can go to the nearest hospital, get the operation done at 1/10 of the cost and recover in 30 months and go 30 days and go back. That is how this medical tourism, Apollo hospitals, all these hospitals in Hyderabad, they became because of the medical tourism only. Here's a procedural cost. What happens in US, the doctor will charge based on his education. So if he is from Harvard, he might have spent crores of rupees in getting education. Harvard is not cheap, right? Harvard medical degree costs around 6 crores. Same MBBS degree in Hyderabad will cost you, even if you take a management quota seat. So that is the difference. If he has put 6 crores, he will charge that money only, right? This guy will charge according to this difference. Free seat guy will complete his education with hardly 50 lakhs cost. He will charge his own. So that is what is all different. So you have to model the behavior based on the data you have. The physician's data is very, very complex. So the models, the procedures, the cost, all depends on the lot of variables which you cannot model. Sometimes you can't model them. That is where the problem lies. We can do clustering, but all Harvard guys will be worth of that? See, Harvard trains around $1,200 doctors every year. Will all 1,200 be equal in terms of knowledge, caliber, experience, and all? If you assume there are equal, then there is no problem. We can say Harvard passed out this much fee. But can we do that? Same thing happens with law. There are lawyers who can't even type proper English. There are lawyers who charge per hour 10 lakhs. Both of them will do same LLB. Okay. Now we will run on this data KNN from sklearn.Neighbours, K Neighbours from sklearn.model selection grid search CV. KNN is equal to K. Now I told you now the problem here is the value of K. What should be the value of K? For that we are using grid search. So what I will do is K underscore range is equal to 1 comma. So it will try K is equal to 1 till K is equal to 20. It will build 20 models. And the model that has the least AIC or the best R square, in this case accuracy. The model that has the highest accuracy will be our best fit. Param underscore grid is equal to dict n underscore neighbors is equal to K underscore range. Grid search is equal to grid search CV, comma, cross validation is equal to 3. Right now I can't do anything. Underscore search is equal to grid is equal to here. Dot fit x, comma. See, if none of the model is fitting, then we go into the data. See, first of all, you do basic pre-processing. Based on your knowledge, you have done the missing value imputations, transformations, some sort of variable selection. You have all done all those things based on the best of your knowledge. And you start building model, basic model, linear or logistic, then decision tree, then random forest, then gradient boosting. You will stop there because these are the models which work really well. And then see if any of these models is giving you a good model with cross validation also you check. If everything good, you finalize the model. If it doesn't work from there, then we go into other models. If it is classification, we go into SVC, Neighbours, KNN. If any of these things work, it's okay. If it is regression, we have to do lasso, ridge, and elastic net, which are penalized algorithms. Now, if none of these things works, we go into neural networks, which are even more complex models. Neural networks require computing power, neural networks, a lot of parameters, all these things will. Once neural networks also are not able to do it, then you go back and see your data. Once you exhaust all the models, nothing is working, then you go and check your data. And then you will come to know by this time what is the problem with the data. Then you can say this data is not suitable for model building. All we can do is exploratory data analysis or a simple cluster analysis we can do, and we will submit it to the client. Now, if you are looking at this thing, in K Nearest classifier, the function is n underscore estimators has to be given here. Sorry, n underscore neighbors. You have to give n underscore neighbors value here. In the function, like random forest and gradient boosting, you give n underscore estimators, right? Here also, in the brackets, you have to give n underscore neighbors. This is a compulsory argument. If you don't give anything, default is 5. If you don't give anything, the default neighbors is, and the default distance is, why we are using Minkowski? Because it is combination of Euclidean and Manhattan. If your data has both numerical and categorical, which is better? Numerical is Euclidean, categorical is Manhattan. Combination of these two is, so that is why they made Minkowski as the default distance metric. Because most of the times we have either fully numeric, we will have numeric as well as non-numeric data. That is why they made it as Minkowski as default. If you want, you can change it to Euclidean. You can see here, metric is equal to city block, which is nothing but Manhattan. The other name of Manhattan is cosine. Cosine is based on cosine similarity. We will study cosine similarity in text mining again. L1 Manhattan, L2 Euclidean, Manhattan, and non-Euclidean, missing value Euclidean. So these metrics are there. Whenever you are giving a K neighbors classifier, we need to specify neighbors and metric. These by default is 5, metric is. So what we have done is, we are not sure whether 5 will be enough. Because our data is large, right? So what I did was, I have given the K range as from 1 to 20 or 1 to 19. Because outer value will be ignored, right? So remember last time programming I told you, if you give 20, it will take up to 19 only. Or if you say you want exactly 20, you have to give 21. And then I define the dict as parameter as neighbors is equal to K range. Dict means key value pairs. Key is the neighbors, value is the K range, which I have given it here. We have to give the range, right? We have to give the model name. In grid search, we have to give the model name, which is KNN. Grid search, you can give anything. Random forest also you can give anything. Grid search will work with any algorithm. Here I am giving model name as KNN. Parameters you have to give. Compulsory n neighbors have to be given. I have defined our parameters here as K range, which is 1 to 21. It goes in iteration. And CV, cross validation is 3 times. I want to check the model also 3 times. So that is what I have done. And then I fitted the model on the grid. Grid.fit x comma y. Now this will build all the models, right from K is equal to 1, K is equal to 2, K is equal to 3, like that. It will build 20 models. And the model that has the highest accuracy will be your final. The model that has the highest accuracy will be the final model. So it is building all the models one by one. First model, K is equal to 1, accuracy. K is equal to 2, accuracy. K is equal to 3, accuracy. K is equal to 4, accuracy. Like that, it will build all the models, get all the accuracies, and then it will give you the final. So once you have completed the building of the model, you simply say grid search dot best params, best underscore params. It will give you the model, the neighbor at which you can build the final model. And accordingly, we will finalize the model. Here neighbors, not estimators. From here only we started. Best underscore params. So for me, it gave us best params is 20. 77.85 is the score. 77.85 for 20 neighbors.
The here A is 0.54. Is also not possible.
Not good. Because there is imbalance in data. The problem is too many zeros and very few ones. Until we correct this imbalance, either reduce this to this or increase this to this using sampling methods. We cannot fit a model.
Doesn't it disturb data integrity?
No, it doesn't disturb data integrity because it will. There are algorithms like SMODE which will build data within the range. So what SMODE will do is it will add more rows on both the classes, yes or no, within the range of values. No outliers are created. So if outliers are created, then you have a problem. If the newly created data means synthetic data is outliers, then you have a problem. If it is created within the range of values, then it is not a problem. I will show you how SMODE works and then you will understand. Then once you balance the data, then your model accuracies will improve and it will, performance also will. That is another thing we have to study. We have to study imbalance in classification. We have to study regularization and regression. Once algorithms are done, we will go through that process. So this is the process of building K nearest neighbors algorithm.
So by far, where we are